Very good morning. As in the previous session, we have seen our temperature sensor. In today's session, we will be observing our next type of sensor, that is LDR sensor. Actually, LDR is light dependent resistor, where it is also called as photoresistor. This is one type of sensor where we can use in some applications, like if there is no light, automatically the light will glows. If there is an enough light, then automatically the light will goes off. We can observe in our mobile phones also our screen brightness. If there is more brightness in the surrounding, then automatically the screen brightness will reduce us. If there is no brightness, then automatically the screen brightness will increase us if it is night times. So like that, it's very good sensor where we can use in some practical applications. And here you can observe, I'm showing a picture like this is your LDR sensor. As the light falling on the LDR sensor, as there is more light, there won't be any buzzer sound. If the light is decreasing, if there is darkness, then the buzzer will make sound. So here we have connected our buzzer and LED with the Arduino. We are interfacing our LDR sensor with our Arduino by the components LED and buzzer. Then we can run this particular Arduino by using Arduino code. Then we can observe our output, the LED glowing and as well as buzzer sound. Then coming to the material which we will use for this making of LDR, it is a semiconductor material such as cadmium sulfide or lead sulfide. Now we will see the working principle of LDR, actually how it will works. It will depend, as the name indicates it as a light dependent resistor. Here the resistance of an LDR decreases where the intensity of light falling and it increases. Means if there is no darkness, that is if it is a daylight, then the resistance will be less. If there is darkness, that is at night times, the resistance will be more. So depending upon that, we will see how it will LDR will works. As here we are showing, this is the simple picture of LDR. It will consist of two terminals here, and it is made up of the material like ceramic. On the top we will be having some electrodes, and photoconductivity material will be there over top surface, and some cold weld contacts will be there. As LDR, here we can observe two arrow marks we are showing with a resistance symbol, and these two are the symbols of our LDR. Now clearly here we will observe the working principle of our LDR, that is, as light intensity is increasing, we can say that our resistance will decreases. So that's what here we are showing. It is dark night time. So if you observe here, the resistance value is more. As the bright sunlight is there, then the resistance value is decreasing. So this is the graph we can see. As depending upon the light intensity, the resistance will varies. Depending upon this, the LDR will works. Here you can observe by this animation picture, we can observe that when there is no light, there is no brightness, there is no LED will close. Why? Because there won't be any path to flow. If there is brightness, then it will the output, the LED will goes off. If there is no brightness, the LED will glows. That is our aim here. In this middle picture, you can observe that the resistance value we are showing here, as it is daylight, the resistance value is very less with 500 ohms. As if it is night time, then the LED value is with 200 kilo ohms. So we can say that the variation of LDR resistance with variation in light intensity is showing in this particular picture. Then we have so many advantages of LDR of our LDR sensor. It is inexpensive and widely available sensor. It will exhibit some fast response time, and it can detect even small changes in light intensity. Means it is one of the characteristic of sensor, that is resolution is high. We can use this sensor either in analog or digital circuits. It is very highly reliable and requires very little maintenance. It will be very lightweight and easy to incorporate in various electronic circuits and devices. So these sensors are very sensitive also. So these are all some of the advantages of LDR sensors. And we have so many applications of our LDR sensors like light meters, cameras, automatic night lights, solar panels we can use. It will store the energy, burglar alarms, electronic toys and gadgets. All these are in toys and gadgets also we can use our LDR sensors to make the buzzer sounds or to move. Lights will glows by depending upon the code. Like that, it will changes in light and trigger different responses or actions it can take. It can do in toys. It can perform. So all these are applications of LDR. We can interface our LDR with Arduino. So the circuit direction connections here I am showing with Arduino, LDR and LED. We are using simple LED. As LDR consists of two pins. One pin is connected to analog pin A0. The other one is connected to our supply. And then LED we are using. LED anode is connected to 11th pin and cathode is connected to ground. And this is the simple code we are using. We are initializing our values. So as 0 first. And I need to read my values in serial monitor, so that in void setup we are going with serial.begin in brackets 9600. As we are using LED here, so LED will be connected to the 11th pin and it is an output. So pin mode 11, output. And LDR sensor is connected to A0 as it is input. So pin mode A0, input. And in loop, we have given simple if else statement where we have initialized already value as 0. If that value is less than 10, then LED should glow. Else, if it is greater than that, then LED should goes off. So that threshold value we can vary depending upon our application. Then serial.println we will be using to print our output in the serial monitor. So this is very simple code. By this code we can run our LDR with Arduino by using our Tinkercad and by using our hardware components. Thank you for listening. In the next sessions we will see more types of sensors. Thank you.